Welcome once again to the next video related with this reaction involves in the rupture of the CO bond. In that the C is reaction with thionyl chloride. So a useful reagent for converting the alcohol to alkyl chloride is thionyl chloride, that is SOCl3. The reaction proceeds through the formation of intermediate alkyl sulfonyl chloride. Here is the intermediate alkyl sulfonyl chloride is formed which eliminate the CO2 spontaneously here, and it will, upon heating, it will use alkyl yield of alkyl chloride free from any interruption in impurities. So here is alcohol interact with thionyl chloride, it will use alkyl chlorosulfonate, which is unstable. Removal of here SO is takes place and it will use on alkyl chloride. So there is the example is ethyl alcohol interaction thionyl chloride, it will use ethyl chloride. Then next is the formation of alkyl nitride and alkyl hydrogen sulfide. Alcohol, much like a reaction with a HCl, react with nitric acid and sulfuric acid when OH is replaced by the NO2 H2SO4 respectively, depending upon what type of the acid is we use. Here is the ethyl alcohol interact with nitric acid, it will use ethyl nitrate. Ethyl alcohol in nitric acid, it uses ethyl nitrate. Here is the sulfuric acid interact with this ethyl alcohol, it will use ethyl hydrogen sulfate, so on. So thus the ethyl alcohol react with the sulfuric acid to form the ethyl hydrogen sulfate, which reacts with another molecule of alcohol and it will use diethyl sulfate. So is the second molecule, it will use diethyl sulfate. Then mechanism behind this reaction is that protonation of alcohol takes place with the help of sulfuric acid. Here is the protonation takes place by giving this hydrogen to this alcohol. So formation of the carbonium ion, takes place here, and reaction of the carbonium ion with the sulfuric acid. So here is a carbonium ion is formed in interaction with sulfuric acid molecule, it will form alkyl hydrogen sulfate. So reaction of second carbonium ion with alkyl group, again secondary carbon, it will use dialkyl sulfate. The next is a dehydrogenation, that is formation of alkene. Here is the alcohol which possesses at least one hydrogen here on adjacent carbon atom to the one holding OH group, undergoes the dehydrogenation in the presence of concentrated H2SO4 and heat, it will use alkene. For example, ethyl alcohol reaction condition same, 95% concentrated H2SO4, 170 to 180 degree temperature, it will use ethene, that is alkene. Here is the secondary butyl alcohol, same reaction condition, only the 60% H2SO4 used and 100 degree temperature is maintained. So it will use rather than 2 butene, it will use 1 butene. And here is a 20% H2SO4 and 80 to 90 per degree centigrade temperature maintained, it will use isobutene. So as clear from the sulfuric acid concentration and the temperature required above all this reaction, that is for tertiary alcohols dehydrate more readily than the secondary and secondary alcohol dehydrate more than that primary. So further whenever it is possible more than the one alkene to form the principal product and is more suitable for the alkene and at a C double bond C system. So this is illustrated by the example of dehydrogenation of secondary alcohol which form the predominantly 2 butene rather than 1 butene. So mechanism behind this reaction, that is mechanism of dehydrogenation of the alcohol following pathway, that is first step, that is the sulfuric acid protonates OH group. Yes, here is protonation, carbonium ion is formed in second step, then proton is removed from the carbonium ion and ion to yield a more stable alkene, last step. So here is a specifically first step is obtained, is acts as a proton acceptor and pulls into the form a carbonium ion. So the ease of the formation of alkene depend upon the stability of the carbonium ion produced during second step. So stability also depend each and every time in case of all reaction, that is a carbonium ion. So since we know that the stability order tertiary, then secondary, then primary, so ease of dehydration alcohol follows same order, and that is a way of the secondary butyl alcohol gives 2 butane rather than the 1 butane. This is of a reason. Then ether formation. If the dehydrogenation of an alcohol with a sulfuric acid is carried out in a presence of the excess of alcohol, here is the reaction condition. At a low temperature, it will use the product diethyl ether here. Then diethyl ether, here 2 molecules of the alcohol eliminate 1 molecule of the water. So here's mechanism is that protonation is takes place first of all, same steps, then removal of the water molecule, it will carbonium ion, then carbonium attack to the second molecule of the alcohol, intermediate oxonium ion is formed, and after in fourth step it is the abstraction of the proton by this H2SO4, here is takes place and diethyl is formed. Then these are all reacted interact, these are nothing but the chemical reaction, and we'll move toward the next, that is a qualitative test for the OH group, that is alcohol. This is a very important point related to the qualitative test or identification test for the alcohol group. This is also in this theory which is also present in your practical, that is the identification test. So we want to know about what are the parameter is important for the identification. So there are the 3 tests which may be applied to detect the presence of hydroxyl group in an unknown organic compound. For this test, take the liquid substance or a solution of the solid substance in an inert solvent such as a dry ethyl or benzene. Then next step is add to it a small pieces of sodium metal. If bubble of the hydrogen are given off, then compound contain a OH group. So here is a sodium, addition of sodium metal, it will use the removal of bubble of hydrogen. It indicates that presence of alcohol group is taken. This is the first test for the detection of OH group. Second is the add to it phosphorus pentachloride here, and if the maximum mixture becomes warm and which evolve the hydrogen chloride here gas, the given substance is contain hydroxyl group. So this is a proof of reaction. Then next test is add acetyl chloride or benzyl chloride to the substance. The separation of the oily layer is thus, and evolution of HCl gas indicated presence of OH. Then how to distinguish between primary, secondary, tertiary. Then another next important thing is related with that, how to identify the OH group in case of the primary and secondary, tertiary alcohol. So detection of the or distinguish or the between the secondary, primary, secondary and tertiary alcohol. So first is the oxidation test. So oxidation, that will also give the idea about our unknown compound is alcohol is a primary, secondary or tertiary is there. So the mode of oxidation of the 3 types of alcohols is characteristic of each type. So in case of first, in primary alcohol, on oxidation gives a aldehyde, and this on oxidation gives a carboxylic acid containing the same number of the carbon atom as the original. So that indicate that this is of a primary, same number of the carbon atom containing carboxylic acid we get from this oxidation. Then in case of the secondary alcohol, on oxidation first gives a ketone with the same number of the carbon atom as the original alcohol, and then ketone is prolonged action with oxidizing agent yield a mixture of the acid, and each contain fewer number of the carbon. So depending upon how much number of the carbon atom we get, in that case we'll get idea about it is of secondary, primary or tertiary, and which type of the compound is formed. In this case we get ketone. Then tertiary alcohol is resistance of, already we know about all these reactions in case of the reaction with oxidation of primary, secondary and tertiary, but we distinguish for it is identification of unknown compounds. So in case of tertiary alcohol, there is a resistance of oxidation of alkyl solution, but readily oxidized by the oxidizing agent that dilute nitric acid to form a mixture of ketone acid which contain fewer carbon atom than the original. So whatever we study, all those reaction in earlier in case of the chemical properties of the alcohol, that are very useful to identify the OH group. So we take in consideration of all those reactions for the distinguish between primary, secondary and tertiary alcohol, as we studied earlier in our other chemical reaction properties of that alcohol. Thus, the identification of product of this oxidation of a given alcohol indicate whether it was primary, secondary or tertiary. So these are the reaction that in case of primary, if it is ethyl alcohol, it will give aldehyde acetic acid by the oxidation, and that gives the same number of carbon atom than as that of original. So that is this particular indication of the products are formed gives idea about primary, secondary and tertiary alcohol is there or not. Then action of the hot reduced copper. So the already that reaction are we studied in the chemical property that is useful for the identification of primary, secondary, tertiary alcohol. In this case, the vapor of the given alcohol passes through the red copper catalyst that is at 300 degrees Celsius. The product obtained is identified. So primary alcohol dehydrogenation to get aldehyde here, and while the secondary alcohol gives ketone, and tertiary alcohol undergoes it will give alkene as that of this reaction gives. So this is the reaction gives idea about the primary, secondary and tertiary alcohol. Vector Meyer test. So this test is based on the different behavior of the nitroalkane obtained from the primary, secondary, tertiary alcohol, and it is carried by the following step, that is the given alcohol is converted to iodide by treatment with the cold hydrogen iodide or the red phosphorus and iodine. The iodine is then treated with a silver nitrate so as to get a corresponding nitroalkane, and the nitroalkane is finally treated with a nitrous acid and dilute concentrated acid, and the solution made alkaline. If the blood red color is produced in this way of original alcohol is primary, blue color is produced at secondary, if it is produces no color it is tertiary. So this is a vector Meyer test. Proper indication of the color gives idea about primary, secondary and tertiary. For example, the specifically for primary red, secondary blue and colorless for the tertiary alcohol. So these are the tests, a vector test that is same catalysts are used and same reaction condition, only the primary for secondary and tertiary give different color reaction and gives idea about the primary, secondary and tertiary alcohol. Lucas test. Next test. So this test is distinguished between the three types of alcohol based on fact easy formation of the chloride followed by order is more in tertiary than secondary and primary alcohol. When unknown alcohol is treated with concentrated hydrochloric acid containing anhydrous zinc chloride, the rate of formation of the chloride as primary, secondary alcohol is so well marked as a given clear indication of what type of the alcohol is present. So this test is known as Lucas carried out followed by a small quantity of the given alcohol is added in concentrated hydrochloric acid containing anhydrous zinc 1:1 proportion as room temperature. When mixture is shaken, insoluble alkyl chloride that commences to form or produce a cloud and the test, and this time taken for the appearance of the cloud formation of the chloride is noted. So tertiary is immediately clouding its place, and in secondary after few times 5 minutes it will give cloud, and in case of primary no cloudiness is found. So the Lucas test is very important test and easily identification of the primary, secondary, tertiary alcohol is takes place by this reaction. So ester test, alcohol react with a carboxylic acid to form ester. The case of the formation of ester order for is more in primary than secondary and tertiary. So difference between the rate of esterification is marked shown in this typical under this examination. So the known alcohol is heated with for 1 hour at 154 degrees centigrade and sealed tube is equivalent quantity in acetic acid. The ester of form isolated in a percentage of alcohol convert into the ester calculated approximately 75%, so that will give ester test in this way.